Hello everyone. I'm recording this presentation because I just want to say thank you, and I want to say thank you and show what your all the data you've inputted into CareView, how we've used it and interpreted it to sort of guide national and local guidance there. I would have loved to deliver it in person, but I'm sure many of you will be aware that I was exposed to a high-risk patient last week, and even though I've had COVID before, I'm having to self-isolate for another 14 days. It's made me the most popular husband and dad in the UK at the moment. But anyway, moving on. These are two CT scans of a patient with COVID. The first CT scan on the left shows the classical patchy ground glass shadowing. It's sort of grey and you can see through it, which gives it its ground glass appearance. The CT scan in blue, which is a coronal section, is a perfusion CT scan. So the blue areas are the areas of the pulmonary vascular bed, which are actually perfused with blood. And you can see these white areas, sort of punched out areas, and those are areas where there is no blood supply to the underlying lung tissue. And that's really quite a unique feature of COVID. That's why they have preserved lung compliance but terrible gas exchange. And that was one of the things we very first noticed back in March when we started looking after these patients and had discussions with colleagues in other centres. Luigi and I wrote up this finding with one of our colleagues from radiology, Michelle Mack. You can see 4 CT scan slices here. All the yellow arrows point to areas of this pulmonary bed infarction. What we think is happening here is that you have very small clots, microthrombi if you will, forming in the capillaries that surround the alveoli and in the very small arterioles that lead to those capillaries too. And that's really a very unusual finding on CT scans, and really something that's almost unique to COVID in our experience. We wanted to try and show that, so we compared it to some historic data. So we've now looked after almost 600 patients. Almost 600 patients on ECMO, and so going back over the last 10 years, we found that we had 80 patients we treated with influenza and just over 50 with COVID. What can you see? Well, about 8% of patients with flu, they have a PE at presentation, whereas almost 40%, or 4 times as many patients, have a PE with COVID. In addition, a quarter of the patients with COVID have additional immunothrombosis. That's to say they've got these areas of infarction, which I just showed you. So over 50% of patients when they present with COVID have evidence of thrombosis or thrombotic disease in some way. And that really is much, much higher than flu by comparison. There's no difference in the rates of intracranial bleeding, and the other striking finding we found from this data was that over half the patients, when we decannulated them, have a deep vein thrombosis. Comparing that historically, you can see Louise Hartley's paper here. She published that last year, showing that only about 10% of patients when they present have PEs, and Chris Lockey and Stuart Gillen's paper that they published 2 or 3 years ago, showing that the rates of intracranial hemorrhage are unchanged in these populations. So we tried to look and see if we could identify anything more significant between the differences between the flu patients and the COVID patients. They're roughly the same age, slightly more men in both populations. The flu patients are a little bit sicker with a higher SOFA score. Flu patients deteriorate more quickly. It's about 8 days before they end up on ECMO, as opposed to 14 for COVID. They have the same duration of run on ECMO too. We didn't see disseminated intravascular coagulation in COVID, but we did see an increased platelet count. So given that we think there's more thrombosis, we looked into the coagulation parameters of those patients who'd had thrombosis and those patients who hadn't had thrombosis in more detail. So patients who had a thrombosis with COVID had a higher platelet count compared to those who didn't. They had a much higher D-dimer than those who did not have a thrombosis, and they had a much higher fibrinogen than those who didn't have a thrombosis. And all of those are statistically significantly different than the flu patients. So particularly if you see a D-dimer greater than 10 milligrams per litre of fibrinogen equivalent units, you really should be looking for thrombosis in them and considering our therapeutic targets, which remain 0.6 to 1 if you've got thrombosis with COVID. I'm very grateful for how for all the hard work that lots of you have put in to make the introduction of 10A monitoring a success. And this was an audit really checking to see had I got it right with the right targets. And what these graphs is show the time that patients spent in the therapeutic range. 10A monitoring is on the left, APTT monitoring is on the right. And what you can really see from this is there's much greater fluctuation in the APTT monitoring. Drilling down into the numbers of that, what has 10A monitoring actually achieved? Well, you get a slightly higher dose of heparin to start off with 10A monitoring, and actually they achieve therapeutic anticoagulation much faster. They almost half of them are achieving it by the time we take their first 10A level, whereas it took 6 to 8 hours for patients with APTT monitoring historically. Most staggeringly, 72% of the time our patients with 10A monitoring are therapeutically anticoagulated in the range we want to achieve. That's absolutely phenomenal and is really testament to their care and precision in delivery of their care that the nurses at the bedside deliver. No one's ever published any number that high in a coagulation series before. If you look at patients who've had metallic heart valves inserted, so more stable and a less complicated group of patients, they only achieve that about 40 to 45% of the time. So our APTT monitoring was excellent, but with 10A monitoring it's even better. Patients with APTT monitoring have just over 3 blood tests a day, and actually with 10A, on average overall it comes down to about 1.3 tests a day, so hopefully it's slightly less work too. So overall, 10A monitoring has been a success, but it's not associated with any increased bleeding, but there is an increased rate of deep vein thromboses. So, what's this data enabled us to do, and where are we going now? So, Fraser and I, in particular, along with a number of others, have rewritten the department's thromboprophylaxis guidelines. The important bit is they sort of uprate the importance of 10A testing and looking for trough levels, and that's summarised in Table 4. This is just going through the thrombosis committee and be on CliniBee shortly. We've also rewritten the 10A testing guideline. 10A testing is going to be expanded for all unfractionated heparin infusions. It will follow the guideline that you're familiar with already. I hope we've been able to learn and listen from your feedback, and just to say that we've gone back to using units per hour rather than units per kilogram, and so hopefully that should help when we're documenting in CareView. So we as a team sort of now lead nationally on anticoagulation and recommendations for anticoagulation and management of bleeding and thrombosis in these patients. So we are approached and asked to do more, which is good, and hopefully together we can improve the care of these patients. I'm really grateful for everyone who keeps filling in the bleeding scores. We may do a trial with argatroban, that's 2 or 3 steps down the line, but actually having historic records of how much people are bleeding and comparing them will be incredibly useful for if / when we do that. And so just want to say thank you. We're also doing basic science, trying to look at disturbed coagulation in COVID and in ECMO, and I'm really grateful for those of you who call Andy Doyle and keep touching base with him to make sure we don't miss any samples there. So I think that's all I wanted to say. Just thank you very much for all your hard work, and what you've been able to document has really helped change and shape practice. So thank you. Hope to see you all soon. Stay safe. Take care. Andy.